Good morning everyone. Today's our topic is azeotrope. Actually it is the topic of class 12th chemistry chapter 1 solution. Okay. So what is the meaning of azeotrope? It is the binary mixture that have the same temperature and have the same composition in the liquid and vapor phase and behaves as a pure liquid. So by taking the example I will explain you the complete term this azeotrope. Okay. Suppose we have taken two component because it behaves as a binary mixture, okay, ethanol and water. Okay, as we know all very well, boiling point act as a fingerprint of the compound. Okay, what does it mean here? Fingerprint, just like a fingerprint of human being, it is not matched with each other. We can identify the human or we can identify the person. In the same way, the boiling point act as a fingerprint for the compound. We can identify with the help of boiling point the each compound, because boiling point never match with each other. Okay, every compound in the universe all are having the different boiling point, whether they can differ in 0.2 degrees Celsius also. Okay, so ethanol and water both are having the two different boiling point. Okay, suppose it is 20 degrees Celsius, okay, and it's of 100 degree Celsius. Okay, if you will boil these two mixture, okay, these two component in a mixture, then first we'll boil ethanol because it is having a less boiling point, and after that water will start boiling. Okay, so which one will be more volatile? Ethanol. More volatile means which can evaporate easily, and which can evaporate easily, which is having a less boiling point. Okay, so in azeotrope we have to take the what? Two component in a mixture. That's why it is binary mixture. Boil at the same temperature. They are having two different boiling point, but if you will fix the composition of ethanol and water at particular composition, both compound, both liquid will have the same boiling temperature. Okay, it will boil at the same temperature. At that temperature we can't identify it is having a two component or not. Okay, because one boiling point will represent the one compound only, one liquid only, but both are having only one boiling point at particular composition. That's why it is written here same composition in the liquid and vapor phase. Okay, and behaves as a pure liquid. Why it is behaves as a pure liquid? Because both are having the only one boiling point. Okay, so we will consider that it is a single liquid, but it is not a single liquid. That's why written here behaves as a pure liquid. Okay, so we can say now in azeotrope it is binary mixture. Second point, boils at the same temperature. Third point, behaves as a pure liquid. And fourth point, has same composition in the liquid and vapor phase. It means x1 must be equal to y1. What is x1 here? It is a mole fraction in liquid phase, and y1 it is a mole fraction in gaseous phase. Okay, in vapor phase. So I will explain you by taking the closed beaker. In that you have ethanol plus water. Here it is liquid state only, so you can represent it by x1 and x2. x1 for ethanol, x2 for water. Here you will get the vapors of both the component, so you can represent y1 and y2. y1 is the vapor phase composition of ethanol and y2 is the vapor phase composition of water. Okay, so in azeotropes you will get x1 is equal to y1, x2 is equal to y2. Okay, it means you can say you can get the fixed composition only when x1 becomes equal to y1 and x2 becomes equal to y2. Okay, so at this point you can consider that two component in a mixture as a azeotropes. Okay, so here two types of azeotropes are there. One is minimum boiling azeotrope. What is the meaning of this minimum boiling azeotrope? If you have two component A and B, just we have taken already the example of ethanol and water. Okay, suppose its boiling point is 10 degrees Celsius and its boiling point is 40 degrees Celsius. Okay, earlier before mixing both were having the 10 degree and 40 degree Celsius, but after mixing at particular composition, now you have got boiling point less than both degree Celsius, both temperature. Suppose you have got 8.8 degree Celsius. This value is less than both, na, 10 degree and 40 degree. This is called minimum boiling azeotrope. It means after mixing you are getting the less value of boiling temperature as compared to earlier one, okay, before mixing. So minimum boiling azeotropes at a certain composition is formed by solution that demonstrate a consistent positive departure from the Raoult's law. Why they have written positive departure from the Raoult's law? You have done already the two types of Raoult's law for volatile liquid. One is positive, other is negative. Okay. So here minimum azeotrope will shows positive Raoult's law. Means opposite sign will be there. If Raoult's law will be positive, then azeotrope will be minimum boiling. Okay, so I will take the example. Why two opposite terms coming here? As I already told to you, whenever any liquid it is boiling at less temperature, means it is having a less boiling point, then it can easily escape into the atmosphere and making a more vapors. Less boiling point will give more vapors, and more vapors means it will exert more vapor pressure. So opposite it is now. Okay, so that's why after getting a mixture, if the boiling point decreases, then vapor pressure will increases. So in Raoult's law, if positive deviation is there, then in terms of azeotrope, the boiling point will be less. Then we can say na, it is minimum boiling azeotrope. Okay, in the same way, if boiling point increases after mixing, okay, more boiling point after mixing, then vapor pressure decreases. If vapor pressure decreases, then it will become the negative deviation of Raoult's law. Okay, so opposite sign will come here. In exam also they are asking many times that minimum boiling azeotrope will shows positive Raoult's law and maximum will shows negative Raoult's law. Okay, in options these questions are coming. So you have to learn the example also, that is very important. Whenever minimum boiling azeotrope example they are asking, then you have to write the example of ethanol and water that has fixed composition of 90%. So what is the meaning of 90% here? Whenever you are getting the any percentage value that is given for the solute, okay, this is given for the solute. Here ethanol acts as a solute and water acts as a solvent. So how much quantity of ethanol you have taken? It is 95. And how much quantity of water you have taken out of 100? 95 it is solute, then how much water left? It is 5. It means only at this composition you will get the azeotrope. It will behaves as a pure liquid. Only one boiling point you will get. Okay, but if you will change the percentage, suppose you have taken 60 and 40, then two different boiling point only you will get for two different liquid. But if you will increase 60 to 80, then 80 to 95, and you will decrease 40 to 5, then you will get this composition. At this composition, ethanol and water behaves as a azeotrope. So one more question arised here, that what is the fixed percentage composition of ethanol and water for minimum boiling azeotrope? So what will be your answer? It is 95% ethanol. Okay, so you can see here this graph. In this graph you can see here they have taken the methanol, okay, and chloroform. You can take on, because in your syllabus ethanol and water is given. Here I have taken the example of methanol and chloroform. Okay, so you can see here before mixing the boiling point of methanol, it was more than chloroform. Okay, but after mixing the boiling point of both, now it becomes only the single boiling point at this point. Okay, and it is less than the value of both cases. Okay, so now it is called minimum boiling azeotrope. Okay, now liquid composition and vapor composition. Here at azeotropes it will becomes equal to each other. Okay, so you can see here this is the azeotropic point. Okay, so next type, it is maximum boiling azeotrope. Maximum boiling azeotrope means you will show the negative variation of Raoult's law. Okay, opposite word will come. If it need more boiling point, then vapor pressure will be the less. Okay, then which example you will have to learn in board. This example only they are asking, nitric acid and water. Here nitric acid act as a solute and water act as a solvent. Okay, so how much quantity of nitric acid you will take? 68%. It means 68 gram in how much quantity, what is how much water it is left here? 100 minus 68, that will be the quantity of water. Okay, now you can see here they can ask this also, at which boiling point it will boil. Means both are having the different boiling point, but after mixing it will boil at the common point, that is 393.5 Kelvin. Okay, so you can see here this graph. Here boiling point of water and boiling point of formic acid both are less, but after mixing the boiling point will increases. But at what composition? At fixed composition. So at fixed composition, if boiling points will become the single point, then it behaves as a azeotrope. Okay, so it is very important, this azeotrope topic. So again I will tell you what is azeotrope mixture. It is binary mixture. Okay, how many types are there? Two types, minimum and maximum. Okay, in minimum, which types of Raoult's law you will show? In minimum, positive deviation of Raoult's law. In maximum, you will show the negative deviation of Raoult's law. Okay, very important question. In both cases you have to learn the example also, ethanol and water plus nitric acid and water. Okay, now our next topic is solubility. Okay, so solubility of solid in liquid now we will do here. We have already done solubility of gas in liquid. So it is according to Henry law. We have done liquid in liquid. It is according to Raoult's law for volatile. Okay, so now our next solubility is solid in liquid. Okay, if you are taking solid, then all we know very well that solid, it can't evaporate. It behaves as a non-volatile. Okay, it behaves as a non-volatile. Okay, it will not evaporate. Then you have to take the 2-3 cases for that. Solubility will increase with temperature, it will decrease with temperature, or it will show some variation. Okay, so first you should know what is the meaning of solubility. How much quantity of solute can be dissolved in a particular amount of solvent, that is called solubility. Okay, if one compound is having a more ability to dissolve as compared to other, then you can say it has more solubility power. Okay, for example, if I will ask from you that sugar, it can easily dissolve in water as compared to oil, then water has more solubility power, it has more solubility ability. Okay, so what are the factors on which solubility of solid in liquid depends? Okay, so our first factor is nature of solute and solvent. Okay, so like dissolve like, Okay, one sentence is there, like dissolve like means polar can dissolve in polar compound only. Okay, polar can dissolve in polar compound only. Okay, so what is polar compound? Which is having a ionic pole. You can say, suppose you are taking a water. If you will break this water molecule into ions, then what you will get? H positive ion, OH negative ion. It has two ions, positive as well as negative. That's why it behaves as a polar molecule. If you will take the NaCl, it is a salt. It is also Na positive and Cl negative. So now it is also act as a polar molecule. So polar can dissolve in polar molecule only. Okay, and non-polar can dissolve in non-polar. That's why this is written here, polar like dissolve like. Okay, like disintegrates into like. Okay, so famous example only taken here, sodium chloride and sugar that can easily dissolve in water. Okay, but naphthalenes and anthracene, it will not dissolve in water because they behaves as a non-polar compound. So to dissolve these naphthalene and anthracene, we need a non-polar compound only, that is benzene. Okay, so one more factor it is written here, that is temperature. Okay, so on temperature also it depends. Suppose you have taken the exothermic reaction. Okay, so in case of exothermic reaction, solubility decrease with temperature. Okay, in Henry also the solubility of gas in liquid, we are taking exothermic process. So here if solid you are dissolving in liquid, if it is exothermic process, then solubility increase with decrease of temperature, or you can say solubility decrease with increase of temperature. Okay, means inverse it is. If one factor will increase, other factor will decrease. Okay, but if the process is endothermic, then solubility is directly proportional to temperature. If you will increase the temperature, solubility will increase. Okay, so one example you have to learn for all. So one example, that is famous example, is there, global salt. Glauber, global salt. So what is the chemical formula? It is Na2SO4 dot 10H2O. Okay, so this example, it is according to the third type of temperature dependent, where first solubility increases, then solubility decreases. Okay, and at this point it behaves as a transition point. This peak point, it is transition point. It means you can say global salt, if you will increase the temperature, first it will increases. Okay, but after particular point it will start decreasing, solubility will start decreasing. So at which point this transition has taken place, this is called transition point. Okay, so what is means how you can say this point is transition? Because at transition point Na2SO4 dot 10H2O, it is going to change the shape of crystals. So at which point it will change now? That is the transition point. Okay, so next factor is pressure effect. Solid and liquids are highly incompressible, so it has very little effect. It means you can't compress the solid and liquid now, so that's why there is no effect of pressure on the solubility of solid in liquid. Okay, so this topic we have already discussed, Henry law. Okay, before the azeotrope we have done Henry law. Okay, so it is very important topic in board. Every time they are giving the Henry law, means they are asking the definition, they are asking the characteristics of KH. Okay, very important. KH value increases as the temperature decreases. This point is very important. Okay, and application also we have done. Okay, So today only we will do up to this only. Thank you and have a nice day.